Hi, everyone. Welcome to the Math One Idea Talks. This talk is on unplugged coding, getting started with unplugged coding. My name is Lesley, and I'd like to say a special thank you to Melissa Seco for being my critical friend and working with me on this presentation and talking a little bit about what you really need to get started with unplugged coding. I acknowledge that I am hosted on the lands of the Mississaugas of the Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. I also recognize the enduring presence of all First Nation, Métis, and the Inuit peoples. My name is Lesley Pike. I am in my 19th year working with the Toronto District School Board. I've taught all grades from kindergarten to grade 6, and I'm excited this year to tackle a new role as a teacher librarian. I also worked centrally for 5 years as a math coach, which was great because I got to work with everyone from kindergarten to grade 9. You can find me on Twitter at Teach Miss Pike. Our learning goals for this session are that you become familiar with the 3 different types of codes or outcomes students learn in kindergarten to grade 3. You get an understanding of what you need in place before you begin to teach coding, and you feel more comfortable teaching coding in your class this fall. Coding allows children to play in the same way they play in playgrounds, communicating, debating, arguing, solving problems, moving, making choices, and following rules. This quote really resonates with me because automatically it draws me into the process expectations and thinking about all of those great things that students do when doing a specific task. And in problem solving with coding, there's a lot of all of this. So it's nice to see. So, what is coding? And why do we start with unplugged coding? So, a code is a sequence, often including both numbers and symbols, that efficiently communicates an instruction or action. And that quote is from Taking Shape, which is a really good resource that's available from Pearson or through Tippett. Now, unplugged coding is different than coding in terms of what you need. So, normally when we talk about coding, we're talking about coding on computers or coding in technology. Most often we see coding using computers or robots, but unplugged coding is a little bit different. We're still using the same commands that we use in those type of codes. However, unplugged coding is a collection of learning activities that introduce coding and programming through engaging games that use only cards, crayons, markers, etc. So things like loose parts. Basically, unplugged coding helps eliminate the equity issue around access to technology. All you need for unplugged coding are things that you already have in your classroom that students use on a daily basis. So where is this stuff? So why all of a sudden are we talking about unplugged coding? Well, in the 2020 math curriculum, which came out in June, under the strand of algebra is the overall expectation of coding, and then there's the specific expectations of coding skills. But before we even get to the grades 1 to 8 curriculum, it's actually found in the kindergarten curriculum of 2016. However, it looks a little bit different. So in kindergarten, we find it in overall expectation 17 under the frame DLMB, and it's describing location and movement of objects. Whereas the specific talks a lot about communicating and understanding of spatial relationships. And what that means is the use of positional language. Up, down, left, right, beside, above. Those are all terms that are used in coding as well. Now for grades 1 to 3, the overall expectation is C3 coding, where students solve problems and create computational representations of mathematical situations using coding concepts and skills. What also is nice is for grades 1 to 3, and actually for grades all the way up to grade 8, is the coding expectation of the grade builds upon knowledge from the previous grade. So the 3 types of codes or outcomes that students are expected to be familiar with by the end of grade 3 are sequential, concurrent, and repeating. So in kindergarten, as I mentioned, there's the positional language, and we tend to do a lot of sequencing codes. Grade 1, we do sequential codes or sequencing codes. Now in grade 2, we still do the sequencing codes, but now we introduce concurrent codes or concurrent outcomes. And in grade 3, once again, we still do sequencing and concurrent codes or outcomes, but now we introduce repeating or looping codes. Now, what do you need to get ready for unplugged coding? So there's a few things you need to get ready. And first, you need a grid. And the grids can be any size, any shape, any color, anything you feel that works best for your students. So you could do a linear grid, which is nice because there's only two directions, left to right or right to left. You can start with a small grid like a 3x3, or you could start with a 6x6 grid. One thing that's nice to have available to students in your class is multiple grids of different sizes. And what this does is it not only allows for student choice in terms of what grid they want to use, it also helps them understand that there are different ways to show things on grids, and that sometimes using a bigger grid is more appropriate, where sometimes using a smaller grid is more appropriate. And that all comes down to the types of mathematical situations you're putting them in for coding. Now that you've got your grid, so also you can print grids at home. So here's two examples of some grids that I printed at home for a number activity I was working with students in grade 3 on repeating grids. And the one on your left is when you select 200% in the printing, and the one on your right is when you select 400. And you can print this easily at home. Like I said, it takes a PDF document. So just make any kind of grid using any kind of word processing program, or using, Google Sheets or Google Slides, and then you save it as a PDF. And when you go to print it, it makes these little marks on the side, and the marks tell you where to cut, and then you just glue it down. So most of the grids, when they're bigger like that, it ends up being about 6 sheets when it's done, 6 to 8 sheets, and then you just piece them together. So you can glue them onto Bristol board and cover it with sheer clear shelf lining paper to help make it more durable. Or if you want to leave it set up permanently in your class, you can get a little side table like this. This one is an IKEA lac side table, and also you can put the clear shelf lining over that, and it just makes it a little bit more durable and makes it easier to use, because once you've got it, you've got it. You can also use things like chessboards or game boards that have a grid format. What's nice about the grid on the right is when you put that on a light table, it really shines through. So that just adds another element to it as well for teachers who are teaching in the early years. And if you're teaching in grades 2 to 3, just go down and ask your kindies if you can borrow it. And it's a nice experience for students. You can also use tape, good old-fashioned painter's tape, masking tape. It could be thin, it could be thick. You could put it right down on a table. Who cares if the lines aren't super straight? Who cares if it gets pulled up? It doesn't really matter, because you can just redo it. So it's a little more time consuming to keep redoing it, but whatever you've got is whatever it can whatever works for you and your students. And you can see here for this one activity that we've put a frame with the direction reference, and that's talking about the arrows, which we're going to get to next. So next you need arrows, lots of arrows, and a start and a stop. So one of the important things to remember when students are creating codes, whether they be plugged or unplugged, is that you need a go, telling you to start your code, and you need a stop, telling you when to stop your code. Now on this one, we've used very specific colors and made sure that the colors are different for each arrow. And the reason we've done that is because some of the research has shown for younger students, or students who maybe have a little bit of difficulty with some of their spatial skills, if they always know that the arrow that's right is yellow, that might help them be able to program to move things to the right. And then that way, as you can see, the left is blue, the down is purple, the up is orange. So associating the color with the direction helps as well. Do you have to do it? No. Do you have to put the words on it? No. You can just, have the students even draw arrows. This was just kind of nice because it ended up getting printed out on a printing card, and it made things a little bit easier. Now the loop is different. It's only used in grade 3 and above, and you can use the loop out of paper. You could use wiki sticks for a loop. You could use popsicle sticks. You could put 2 crayons down on your grid, whatever you want your students to use to show that what is within those sort of brackets, or those, that little loop, needs to be looped or repeated before proceeding on to the next part of the code. Now, the other 2 arrows are a little more of a synthesized idea. That's where you're moving a direction and doing another direction at the same time. So usually we see this when you're going to the right and down, or you're going to the left and up. That's a little bit more of a sophisticated arrow that I probably wouldn't start to use until my students were in grade 2 or 3, but that doesn't mean you can't use them in kindergarten or grade 1. You know your students best, you know what they're capable of, you know where their ideas are going. So just be there to facilitate and guide them. Now you need something to write code on. So we've got our grids, we've got our arrows, but how are we writing down our code? So you can use written code strips. And these are just strips that are out that you can make, once again, using any sort of word processing program. And they can be all different sizes. And if you look at the one on the right, it's not going from left to right. It's actually going from up to down in a linear format. So that's kind of nice to use as well. So students don't always get used to seeing codes written in one particular way. And I would also actually advocate as well not to put stops on your code strips. These were used for a different purpose, but I wouldn't put stop because then you're limiting how many or how few steps a student can use in their code. And every situation is different. And so we don't want students thinking that if there is, for example, on the bottom one, there's eight squares. One's taken up by the go, one's taken up by the stop, but their code can only have 6 actions in it or 6 commands. Sky's the limit with however many you want to have. Another example of written codes could look like this. You could have the instructions of the little different directions above, and then you can have them put their own go in, their right, their stop. Eventually, too, you want them to start to no longer just write, right arrow, right arrow, right arrow, right arrow. You want them to put right with a 4 beside it. So then that way we know that we're going right 4 more times. And that's all about sort of becoming more mature in writing codes and synthesizing our ideas. And that's where the code sheet on the bottom, where it says write the code sheet, where it says code 1, code 2, code 3. Using something like that is a great way to get students to actually try the code. So work through a little bit of a trial and error and debug and problem solve and sort of, change the context of the problem. So in code number 1, you were able to go from your house to the well in 8 steps. Can you do it in less steps? What would that look like? How would you go? And it just gives you some of that flexibility when you're giving the students opportunities to code. So eventually we take them from the easiest way to code to a more efficient way of coding. Lastly, you need to think about storing it all. And you can use simply, you can use Ziploc bags. You could put everything in one big bin. However, you are going to need to be able to access these fairly quickly to get to the actual coding and to get to the actual math behind it. So you might want to invest a little bit of money maybe in some containers or such. Also, too, we know now, teaching post-COVID, it's a little bit different. So when using the Ziploc bags and having the students all cut out the arrows and having their own set also eliminates some of that cleaning issues and some of the sharing issues. So here is just one way that you could store. This is a bead container actually that was purchased at Louise Cool and Gold. It's got 10 compartments. And what's nice is the arrows fit in it. And you can see these were just some arrows that were found online and cut out and used. They do look a little bit different than the ones I showed you earlier, but there's no right or wrong way to make an arrow. It's whatever you find, whatever you feel comfortable with, whatever your students feel comfortable with. But what's nice about this box is it also gives some space for loose parts. So as we said again, if every student has their own, then you're not worrying about having to clean them every time. And students can actually just pull them right out of their desk, use them, put them right back in their desk, and take care of everything that way. The next one is some that I purchased at Dollarama. As you can see, it started off as a kit with 12, and I've put what I call my base kit in. And my base kit is just a start, stop, and a bunch of different arrows. And the reason why I call it my base kit is when I'm working with students, sometimes we use different pieces that are a little more that have more to them. So we still need the arrows, but we need something else. And so they know to grab a base kit and grab something else. What else I like about this is I could just easily write in tape on top of it a student's name. And then that way, once again, it's one student using one kit. As I said, this is now my Code Central. I purchased this at Canadian Tire. I think it was about $10. But what I find helpful more when I'm working with the kindergarten and grade 1 students is that I can store all the individual pieces in here. So you can kind of see there's one I've got there with some leaves because there's an activity I do with some of them that involves gathering leaves. So the students would grab the base kit and they would grab one of these, and that helps set the context for the problem that we're doing using coding. At the bottom, if you can kind of tell on the bottom left, is I use binder clips. And the reason I use binder clips is students can either have everything lie flat, but if they're using themselves as part of the code, or they're using a character from a story to do a retell, which is a sequential code, then that way they can make it and have it stick up 3D, and they can use the arrows and such and put it in. So now instead of just being flat, it becomes 3D, and that kind of gives students a little bit more fun. And it's neat to kind of see as a teacher where there's the grid and then you've got all this sort of stuff popping up on it. It's just another dimension to it. You can also store loose parts in containers. Once again, dollar store is a great place. The one on the left is actually a mirror from Dollarama, and you can see all the loose parts and the loose people that are used in there. And the one on the right is actually a cutlery box that was found at Value Village. So that's another nice place and nice resource to look as well. So that is just a little bit on what you need to get started with Unplugged coding. If you have any questions, you can reach out to myself or to Melissa Seco. You can also follow us on Twitter or follow Melissa on Instagram, where we post lots of pictures and ideas of Unplugged coding in classrooms. Thank you so much and have a great day.